Hi everybody, welcome to Raaonline. I am Dr. Priyadashini Shanmugam, Professor of Microbiology, and today I am going to talk to you about Vibrio and cholera. So what are Vibrios and what is the disease known as cholera? So today's learning objectives will be what is Vibrio cholerae, how it is different morphologically from other bacteria, and certain characteristic features about Vibrio cholerae, example its motility and its culture properties and all that. And another thing is the pathogenesis of cholera, that is how we get the disease and what are the clinical manifestations of the disease and how do you diagnose a case of cholera in the laboratory in addition to the clinical diagnosis. Vibrios are gram-negative curved rods. Rods means they are bacilli, so they are either stick or rod shaped and they are gram-negative when you do the gram staining, and they all belong to the family Vibrionaceae. Vibrionaceae are characterized by this curved shape and they all have a single polar flagellum. That is, there is only one flagellum at one end of the bacteria, so it is known as polar, and so this term is also called as monotrichous, having a single flagellum at one end or one pole. So all of them are gram-negative rods and they are motile by means of an polar flagellum. And the motility is active. In fact, it is called as a darting motility because it moves so fast and out of the observer's field of vision. And the most important member of this genus Vibrio is Vibrio cholerae, which is a causative agent of cholera. And this Vibrio cholerae was first isolated by the great scientist Robert Koch from cholera patients in Egypt. So only after that they came to see what is the organism causing the disease. Vibrios are ubiquitous, meaning they are found all over the world, all across the environment, but there is one special character in that they are salt loving. They also always like a little bit of salt in the environment in which they are present. So that is why you are finding a lot of Vibrios in the marine environment. And several species of Vibrio will infect man, but the most common, as we already discussed, is Vibrio cholerae, which causes an acute, sometimes a devastating diarrheal disease, which is still rampant in developing countries like India and can even lead to death in untreated cases. And Vibrio cholerae will be the main organism which I will be concentrating on. And before going on to Vibrio cholerae and cholera, Vibrios are also classified as halophilic and non-halophilic based on the salt tolerance and the amount of salt, that is sodium chloride, which is required for the organism to grow. So halophilic Vibrios are those which can grow up to in environments which are having up to 10% of sodium chloride, whereas non-halophilic is around 1 to 2% of sodium chloride. Example of non-halophilic Vibrio is Vibrio cholerae and Vibrio mimicus. And halophilic Vibrios, an example will be Vibrio parahemolyticus and Vibrio alginolyticus. So they are halophilic Vibrios, and some of them can also cause diarrhea, they can also cause food poisoning. And whereas Vibrio cholerae, the common agent which causes cholera, is a non-halophilic Vibrio. And now coming on to the morphology of Vibrio cholerae, before going on to the disease as such, we have to know that they are very short bacteria, they are curved and cylindrical. So we call it as comma shaped. So you cannot expect a perfect comma in your gram stain, but you can see some bacteria which are slightly curved, as you can see in this one and this bacteria. And what you notice is that this curvature, you can see it only in fresh isolates as well as in fresh samples with cholera, like cholera stool which you are collecting. Only in those samples you can see the Vibrio cholerae with the curved appearance. As you keep maintaining the culture in your laboratory and as you keep subculturing the organism, it loses its curvature. And its length is around 1.5 micron. So all the measurements are in microns. So micron is 1 by 1000th of a millimeter, okay, or 1 by 10 to the power of 6 of a meter. And the diameter is 0.2 to 0.4 microns in size. So the length is about 1.5 microns. And in staining like gram stain, you can see that all the Vibrio will be usually arranged in parallel rows. So they look like fish traveling in a stream. So this is known as a fish in stream appearance, which is very characteristic of Vibrio cholerae. And regarding the motility of the organism is actively motile, as already discussed. That's a characteristic of Vibrio itself. It's got a single polar flagellum which has got a sheath. So it's known as sheath, means covering. So it's a sheathed flagellum and exhibits darting motility. That means the bacteria moves so fast that they move here and there and then they move out of your field of vision. So you will not be able to focus on any one particular bacteria because it moves so fast. So it's darting, that means like an arrow. And another terminology which is used to describe this motility is known as a swarm of gnats appearance. So when you take the stool samples from acute cholera cases, so when you examine the stool sample from a case of acute cholera or from a young culture, as I told you, when you have just done a fresh subculture, you will see all of these Vibrio moving around so fast. So it will be like gnats are nothing but flies. So it will be like flies buzzing around some food, or you can see bees buzzing around a hive. So that kind of appearance it gives you, swarming around a hive, the bees, or you can see these flies swarming around some fruit or some food item like that. So that is why it's known as a swarm of gnats appearance. So two phrases to describe the Vibrio. One is with respect to the motility, that is known as swarm of gnats appearance, and regarding to the staining, it is known as a fish in stream appearance. Okay. And the commonly used stain in microbiology, we all know it is Gram stain. So in Gram stain, it is Gram negative. It is not acid fast. So it is not an acid fast bacteria and it does not produce any spores. And this is another stain which is used to demonstrate the flagella. Here you can see the flagella are so long, they are much longer. They can be up to 20 microns in length, whereas the bacteria is so short. So the flagella are longer than the bacterial body, and this is a kind of stain known as the Leifson's flagellar stain. There is another stain which stains the flagella, it's known as the Reuss stain. So there are two stains, RYU, Reuss stain, and the Leifson stain. So this is how this organism looks when you do a flagellar staining. You can see the single polar flagellum. So far we saw about the motility as well as the morphology of the organism. Now we will go on to see about one important toxin that this organism has within it, which produces, and that is responsible for causing all the clinical features of cholera.